Hey everyone, and welcome to The Explainer. Today we're diving into something pretty mind-blowing. We're actually decoding the secret language of our daily lives. We constantly go about our day without even realizing that math is literally happening everywhere around us. It's this hidden framework behind, well, everything. From figuring out if that grocery bag is going to be way too heavy to lug home, to knowing exactly how much petrol we're pumping. By the end of our time together today, you're going to see the world of measurement in a totally new, crystal clear light.
So consider this. How much weight can an ant carry? Or, jumping to a totally different vibe, exactly how much water makes 2 perfect cups of tea? These aren't just fun little trivia facts, they're real-world measurement puzzles. Whether zooming way out to weigh massive cargo or zooming incredibly close to check out tiny insects, measurement is the tool we use to just make sense of it all. So keep those 2 questions tucked in the back of your mind as we go along today.
Okay, let's dive right into this. Here is our agenda for today. First, mastering the weighing scale. Then, grams and kilograms. Third, the tiniest weights. Fourth, measuring everyday liquids. And finally, real-world measurement problems.
Part 1. Mastering the weighing scale. You've probably seen a standard digital scale just like this one in your kitchen or at the local grocery store. But here's a crucial first step that people forget all the time. You've got to understand how the zero works. Before you drop a massive 5-kilogram bag of rice on there or even a heavy bucket of water that's 1 kilogram and 800 grams, that scale absolutely must read a perfect 0. If it's off by even a tiny bit, all your math later on is going to be completely wrong. This kind of scale, it's your go-to for those everyday, medium-sized things around the house. Now, contrast that rugged, everyday tool with a precision scale. These things are so sensitive, they're actually kept inside glass cases, just so a random breeze doesn't mess up the reading. I mean, you definitely wouldn't chuck a 5-kilogram bag of rice on this thing. Different settings require totally different tools. If you're weighing something super delicate, like a lightweight gold ring, you need a highly sensitive instrument. It's a great reminder that you've always got to match your tool to your task.
Part 2. Grams and kilograms.
So, the absolute crucial point we need to lock in is this golden rule right here. 1 kilogram is exactly equal to 1,000 grams. The word kilo literally means thousand. So whenever you see a weight creeping up past 999 grams, boom, you cross the threshold right into kilograms. Getting a handle on this relationship is a real game changer because it lets us convert big, clunky numbers into simple, easy ones. Let's actually bring that rule to life. Picture this. We're looking at Harpreet's family picnic packing list. We've got a watermelon at 3 kilograms, mangoes at 2 kilograms, a pineapple at 1 kilogram and 750 grams, and some apples at 1 kilogram and 250 grams. So, applying our rule, what's the heaviest thing in the basket? It's definitely the watermelon, sitting at 3 whole kilograms, which, if we convert it, is 3,000 grams. And the lightest? The apples, at just 1 kilogram and 250 grams. Once you know that the thousands place is basically your kilograms, comparing all these mixed up weights becomes a total breeze.
Moving on to part 3, the tiniest weights.
Okay, let's shift gears and zoom way in. Think about a tiny, single-serve packet of sugar. That weighs just 5 grams. Super light, right? But for an ant, even a single gram is a massively huge unit. For things that small, we use a unit called the milligram. And get this, there are exactly 1,000 milligrams squeezed into just 1 single gram.
This fact absolutely blows my mind. An average ant weighs somewhere between just 1 milligram and 5 milligrams. Think about that for a second. That 5-gram sugar packet, that's 5,000 milligrams. And yet, despite weighing literally next to nothing, ants can haul around blocks that are way heavier than their own bodies. It's honestly just an incredible feat of nature, and we can only really wrap our heads around it because we have this specific mathematical language, the milligram, to measure it.
Part 4. Measuring everyday liquids.
And there it is, that magic number again, 1,000. Just like there are 1,000 grams in a kilogram, there are exactly 1,000 milliliters in a single liter. I love how beautifully consistent this math framework is. Whether you're weighing a solid object or measuring out some liquid, this rule of thousands is always going to be your best friend. Check out this delivery log for Kayal Chacha's weekly milk rounds. Look at how totally unmanageable these numbers get if we only stick to milliliters. The Srivastavas family, 12,000 milliliters. The Das family, 20,000. The Rao family is up to 25,000. I mean, that is a ton of zeros to keep track of. But if we just apply our rule of 1,000, we can divide by 1,000, basically just chopping off those 3 zeros, And suddenly it's so simple. The Srivastavas get 12 liters. The Das family gets 20 liters. Converting those giant milliliter numbers into simple liters saves so much time and really keeps you from making mistakes.
And finally, part 5, real-world measurement problems.
All right, let's put it all together with a classic scenario. Imagine we're hanging out at a petrol pump with two friends, Sam and Tina, and they're filling up their bikes. Tina buys 2 liters and 500 milliliters of petrol. Now Sam buys 2 liters and 800 milliliters more than Tina. Notice that's not his total. He bought that much more than her. So how on earth do we figure out exactly how much petrol Sam actually bought?
Let's look at how Sam handles this, because his step-by-step logic is brilliant. He completely organizes his math. Step 1, he isolates the big units, the liters. Tina's 2 liters plus his extra 2 liters gives us 4 liters. Okay, step 2, he adds up the smaller units, the milliliters. 500 plus 800 gives us 1,300 milliliters. Now step 3, he spots the rule. 1,300 milliliters is over 1,000, so he converts that excess. That 1,300 turns into 1 liter and 300 milliliters. And finally, step 4, he just merges the whole thing together. The 4 liters from the start, plus that converted 1 liter and 300 milliliters, gives us a grand total of 5 liters and 300 milliliters. By just breaking it down piece by piece, a really intimidating math problem becomes honestly a piece of cake.
Wow, we have covered a ton of ground today, unlocking these cool measurement secrets from tiny little ants all the way up to big petrol tanks. So I want to wrap up this explainer by leaving you with one final puzzle to noodle on. If a factory has 8 liters and 400 milliliters of oil, and they need to pour it equally into 7 containers, exactly how much oil will go into each container? How would you tackle that? Would you convert everything to milliliters first, or try dividing the liters and milliliters separately? I'm going to let you calculate that one in your head as you go about your day. Thanks so much for hanging out with me for this explainer, and hey, keep looking for the math hidden in your everyday life.